So we're going to go to startup presentations. So like I said before, we have 7 startups on stage, and they're across a number of different technologies related to energy, including AI, machine learning, IoT, battery charging, and portable energy. They're also at different stages of development. Some of them are pretty early, some are much more advanced. So keep that in mind. They're each going to be talking for 4 minutes. There's not going to be any Q&A, but there will be a break afterwards, and all of them are going to be outside beneath a sign, beneath their logo, so you can find them easily. So our first speaker is Alex Gruson, CEO of Witricity. This is a Stex25 company from our accelerator. He holds a bachelor's and a master's from Aeroastro at MIT, and they make a technology that enables wireless charging of electric vehicles and consumer electronics. So this and this one. Perfect. For Ford.
Perfect. Thank you. So this pitch I gave Tuesday morning at a conference on electric vehicles, it took me 32 minutes. So I'll apologize for speaking quickly today. Witricity was founded in 2007 by a professor in the physics department and his research team. As any tech company, and many of the ones you'll hear from today, you spend a few years evolving your technology and looking for product market fit. And for Witricity, the focus is electric vehicle charging. In fact, a year ago, I took our whole team and focused 100% on EV charging. Why? So our technology is uniquely capable of solving the challenge for charging electric vehicles. All right, so on 6 fronts. That we power as efficiently as plugging in, 90 to 93% from grid all the way to the battery of the car. You have parking flexibility. You don't have to park particularly accurately. We charge as fast as conventional plug-in. So all the systems, for example, we're shipping to automakers today are 11 kilowatts, again, just as efficient as plugging in. We can power through materials, so you can be on the driveway or even in the road or in the garage concrete, and snow and ice and the like don't matter. One common ground infrastructure can charge a sports car, a sedan, or an SUV, or even a bus, right, but with no moving parts. So you have that X, Y, and Z flexibility. And the technology lends itself to both static and dynamic charging, so in the future, dynamic roadways. But we also have very active work going on bidirectional power. So you can flip it, and the car could deliver power to the grid. So for grid stabilization, or powering a home in the case of natural disasters for 2 or 3 days. So why does this really matter and important to the world's automakers? We're working already with the vast majority of the world's automakers. We've built a global standard with the Society of Automotive Engineers. The reason is these electric cars are beautiful, but charging cables are not. The experience of wireless charging is awful. If somebody has an EV today and tells you, oh, they don't mind, they're not the mass market, all right? 1 to 2% of autos sold today are electrified. It's early adopters. It does not reflect the broad population. I've been in consumer products business for 20 years. It doesn't extrapolate. Our automakers are concerned about adoption of new behaviors, all right? So going from being reactive, my gas tank is empty, to I could go fill it up in 5 minutes and not have to worry about it for a week, to having to plan every single day, do I have enough fuel or enough range in my battery to do the things I need to do today? And that's just the things I know I need to do today. So they want to make charging really simple and something consumers don't have to think about. If they don't do it, people won't buy EVs. If they don't buy EVs, they're going to have to price them down. It'll be like corporate average fuel economy requirements that came in. Nobody wanted the efficient cars. They wanted the gas guzzlers. Automakers lost money. So the goal here is to make consumers want an EV because it's a great experience. First customer coming to market is BMW. They're already in the market advertising their upcoming plug-in hybrid with wireless charging, and I love the tagline, all right? BMW wireless charging makes charging easier than refueling. In other words, having an electrified vehicle is preferable to having a gas engine. That's the message we're trying to get across. Sorry, next slide. There we go. We're also setting the stage for the future of mobility. Think about it. There's a lot of talk about LiDAR and machine learning and sensors. Wireless charging is just as important. these fleets of robo-taxis, they've got to pause, recharge. It's opportunity charging. I call it power snacking, but in the service area, not going to some distant depot to have someone plug them in. So think about us as central to the shift to mobility as a service. And finally, an infrastructure opportunity. 99% of the electric vehicle charging that's going to happen is 11 kilowatts or below. That's our current sweet spot of our technology. We can scale up, but we're there now. So there's a lot of talk about DC fast charging, but all the charging is going to happen at home or at night, and even public infrastructure is going to be 96% level 2 or below, which we can serve. So finally, just think about Witricity as an enabler of charging as a service and a key element of your future smart grid, and look forward to talking to you. Thank you.
Thank you, Alex. Next speaker is Fausto Morales. He's a data scientist at Arundo, which is a new STEX 25 company. He holds a bachelor's in civil engineering from MIT, and Arundo makes an OS for managing industrial and energy assets digitally.
Thank you, Marcus. So yes, my name is Fausto Morales, and I'm a data scientist at Arundo, a software company providing tools for heavy industry to enable advanced analytics and machine learning. I won't be the only MIT alum from Arundo you'll hear from today. Tor Jakob, our founder and CEO, will be speaking on the panel later today. I actually, after joining Arundo last year, I learned later that Tor Jakob hails from Course 15, which normally would have required me to immediately tender my resignation. But by then, I was already really excited by Arundo's goal to transform heavy industries through data-driven insights. And the way that we seek to do that is to bridge a gap that exists today in industry. Imagine that you work at a major oil and gas company, perhaps in a refinery, and you have a data science team that has developed some really great predictive maintenance model for a unit at your refinery in conjunction with a contact engineer in operations. And this new model can predict a process upset with a day or 7 days notice and prevent all kinds of costs, and everybody is throwing a party and popping champagne, and the refinery manager is thrilled, and everybody's getting raises. But now you need to actually deploy that model so that it can be used to actually make decisions. The data scientist has a Jupyter Notebook. If you're in the data science field, you'll know what that is. And the contact engineer sits in a control room somewhere in a refinery in the Gulf Coast. And there's not really a way for them to work together to get the business improvement that they were looking for. And so you turn to your IT department or to coworkers of the data scientist, and you get somebody in DevOps to put together all the infrastructure. You get a bunch of developers to build the UI and to make it very resilient so that it can handle the actual operational context of being in a live environment. And a front-end developer that's going to make sure that the folks in operations are actually comfortable with these tools. And they're all going to work together, and this is all going to work out just fine. And if you actually work in an oil and gas company, I presume that you know that this is going to take years. It's going to take a very long time to get all these people together. This is actually coming from my experience. Prior to working at Arundo, I spent 5 years working for a small energy company out of Dallas called ExxonMobil. And this is a major barrier to actually getting these data science tools to market. So what Arundo provides is tooling that makes sense for the folks in operations and for the folks on data science teams. Data scientists get tooling to enable model deployment into a common environment that is resilient to all of the issues that come up in in refineries, in plants, on ships, etc. And by the end of it, you're able to get a user interface that's usable by everybody in the company. You have data being streamed into the cloud directly in order to allow more models to be deployed. So once you've actually set this up, data scientists can test new models and show the results to people in real time. And this is something that we've actually done in reality with a pump manufacturer to enable them to avoid having to develop new capabilities in order to deploy models. Arindo is a company seeking to enable oil and gas companies and other heavy industry companies to take advantage of data science and all of the tools that it offers. And if you're interested in that, I hope you'll please come talk to us. Thank you.
Thank you, Fausto. Our next speaker is John Garrity, CEO and co-founder of TagUp, another STEX25 company. He holds a bachelor in physics and economics from MIT. Instead of getting his course 15 at MIT, he went across the river, which I think is probably even less reputable. Just kidding. And they make an IoT technology for monitoring industrial equipment.
Thanks, Marcus. And then clicker. Perfect. So good morning, everyone. I'm John Garrity, one of the co-founders and CEO of TagUp. Started the company almost a few years ago with a classmate from MIT, a fraternity brother. His background was in machine learning, a PhD at CSAIL, and I worked in industry at GE, and so we kind of brought our heads together and realized there was a real opportunity to apply some of his research to predict equipment failures. And the challenge we realized is that machine learning requires a lot of data. And so when we were trying to do it in industrial applications, it's very hard to get that data. Right? Anyone in industry knows the data is maintained in a lot of different sources. It's very difficult to access. And we realized, to enable the sorts of capabilities that, for example, GE had with steam turbines, where they could see the real-time status of 1,700 plus steam turbines around the world and provide diagnostics and service to their customers. To enable that sort of capability, we needed to build a data platform. And so we've built an end-to-end IoT system that collects data from equipment in the field, all sorts of different asset types, makes the data available in a canonical format so that we can build data science models on top of that operating data very easily. And we're very focused on specific equipment types. So, I think Kalyan mentioned earlier that data is really key for these sorts of projects. The more data you get, the better the models. And so instead of focusing on a lot of different asset types or a lot of different verticals, we've been very focused with energy companies, looking especially at transformers initially. You might recognize the photo at the bottom. That's the Prudential building. There was a big transformer failure in 2012. All the Back Bay behind you was blacked out and smoke going down across the skyline. Bad PR, very expensive, high cost of failure. And the question is, can we use an IoT system and data analytics to prevent that, to make more informed decisions? So I'll talk about an example project. So we're working with Con Edison in New York. They have a lot of transformers. In fact, they have over 27,000 of them. We're collecting data from their data systems, sensing instrumentation, so things like the loading on the transformers, the pressure and temperature, the oil in the tank, and also a lot of metadata. So who's the manufacturer, when was it built? All this data comes into our platform in an organized fashion, and then we apply machine learning analytics that my co-founder developed on top of that data to make useful predictions, in particular predicting failures. And so we received operating data from 2004 to 2016, and we're told to predict 2017 failures, and we were able to do so with 99.5% accuracy. So really high accuracy levels, and a lot of that's driven by the quantity of data, terabytes of data that we were able to receive, and a huge number of failure examples. So we had a very good existing data set of failures in the past, and we were able to apply these models to infer in the future what might actually fail. The challenge for us now is generalizing these models, so seeing if we can apply them to other operators, and that's where the data platform comes into play, where we specify the data format required for these assets so that the models can be run on an ongoing basis on any utilities equipment of the same type. The business case, the value proposition comes in a lot of different ways. Principally, it's safety and reliability. Obviously, transformers filled with oil. These are pictures from Volts in Manhattan where these transformers sit. So network transformers are used in high-density urban networks. There's a lot, almost 1,500 in Boston as well. They change the voltage level from the grid to the load, and they sit under the street. So you can imagine if you have a fire or explosion, a manhole cover can go up really high. They can cause a lot of damage, especially in a city. And so that's the key priority. Second to that, though, there's lots of applications for improved inventory management, procurement, and also improved inspection efficiency. So now you can really target specific assets for inspection. A lot of different applications. We've been excited to have a lot of great partners off the bat, and would love to chat with anyone who would like to learn more after. Thanks.
Thank you, John. Next speaker is Maren Katunar, co-founder of Automated Analytics. She's a former ILP program director, so some of you might recognize her. And the company makes big data image analysis for oil and gas exploration.
I'm a little sad I don't have the foam microphone here, but anyway, thank you very much, Marcus. Thank you for the MIT ILP for having us today. We're really excited to be here. I'm also joined by my co-founder, Dr. Alon Arad. He was in the mathematics department at MIT for 4 years, and we both realized that there was a major problem, a big data problem. And what we actually discovered, I spent 9 years in the aerospace and defense sector working on sensors, and we like to make things more accurate, more precise. And we focused on the sensor side, and the processing side always came a little bit later. My colleague headed up computer vision in one of the large oil and gas companies for 5 years and came across a very similar problem. In the oil and gas sector, you take very large slices of rock, using really advanced imagers, micro CT scans, microtomography, or SEM scans. And those images are 16 gigabits a slice. So my colleague, he said, well, this is a really big data problem, and processing these images takes a really long time, and the existing platforms aren't that good. The existing platforms are clunky, they crash, they're homegrown, and they're just not robust. In some of these oil and gas companies, and I won't name names, people are handling this information on memory sticks, and they're handling it on an external hard drive. So configuration management, data management is a challenge. And then at the same time, being able to visualize a 16 gigabit image, you usually need specialized software, a specialized platform, and processing usually takes 3 hours. Most scientists leave it overnight to process it. So we decided that's just not the way things should be, and we stood up Automated Analytics. It's a GPU-based, high-performance computing image processing platform. When I say platform, the drug delivery guys love this because it's applicable to multiple sectors, and actually our platform is as well, and it can also handle video processing. So it's on the cloud, and it is also, you have the opportunity to have it on-premise, so you can keep it behind your particular firewall. And rather than downloading clunky software, we actually have it based on a web browser. So you can file, you can catalog, you can search, and you can filter. One of the things that we've been doing is talking to different potential customers to understand what do they need. And we learned that they actually need things that are Apple-like. So that's what we've tried to do. So drilling down to the rock, because we like rocks, for enhanced oil recovery, this is a standard slice of an image. And what we're able to do is have the same functionality that existing platforms have, but rather than having processing times in hours and days, we can process something in 30 seconds. And there's no need to download any clunky software. You just need a web browser. And like Google Earth, you can view that high-resolution image from anywhere. A mobile device, a tablet, you can share and collaborate. So talking about collaborations, our first customer and our teammate, essentially, is the University of Houston's Petroleum Engineering Department. We have an instance of our software there, and what we are doing with them is understanding the parameters for enhanced oil recovery and using our platform to enable that in a more expeditious fashion. They like the tool so much, we're actually standing up a consortium with them It's RPM3. I'm not going to give you the tongue twister, but it's essentially for digital rock physics. And in addition to that, because our processing is as fast as it is, we're going to use our back-end processor with a partner, Hydroswarm, which is creating unmanned underwater vehicles, and we will take seismic measurements and sonar measurements with that team to do seafloor mapping for offshore oil exploration. So thank you very much. We look forward to talking to folks because we are looking for customers, partners, and really fundamentally understanding the requirement sets. Thank you.
I'll need that. Thanks, Maren. Next speaker is Spin Wang, CTO and co-founder at Tetra Science, a new STEX 25 company. Also a master's from the Department of Electrical Engineering and Computer Science at MIT. And he's going to talk to us about mission control for the energy R&D labs.
All right, everyone. Hi, everyone. I'm Spin Wang from Tetra Science, CTO and co-founder. So Tetra Science drives data integration for R&D labs, essentially research and development labs.
The green one.
So for a lot of energy labs, based on our research, this is the status quo. The labs are semi or unconnected. Namely, what I meant by that is you have a lot of scientists, data systems, lab instruments that are producing a lot of valuable data. The analytics software that are using to analyze those data, they are simply not connected. It is very manual process for the scientists to move data from the instruments to the software they need to analyze the data. And we just heard from our customer that they have to do some experiment for 3 times in the last quarter just because they couldn't find the data they have actually produced. It is a very common problem in life science and also in energy industry, especially in the R&D stage. So what we want to provide is almost like a data highway system that is have the ability to connect all those disparate systems into one traffic system, such that the scientists don't have to manually transcribe data from A to B. The data is able to flow through this network. This network is able to provide vendor agnostic data normalization, and also we provide a persistence layer that you can search the data that is passing through, almost like a traffic system. So as an integration platform, I want to talk about the integrations we provide. The first one is actually pretty simple, file-based. There are a lot of instruments that produce files, and actually one of the trends that we're observing in the industry is that there are a lot of outside collaborators that are performing experiment, performing some study, and send the result back to you. So essentially what we do is to integrate with companies, our customers' file storage system, pull the data out, perform automated parsing, validation, and data normalization, and then store the data or provide some visualization, and then push the data to some lab information system, data analytics softwares. So we do not analyze the data, but we pass the data. We're like the delivery man here. There's another example. There are a lot of instruments in the energy labs those are very complicated and huge instruments, such as liquid chromatography, mass spec, and so on and so forth. What we do here is to integrate with the software that comes with those instruments and put the data into our integration platform, and then provide it for downstream application. There are also instruments that are simply not connected. There's no way for you to talk to that instruments using a computer, but it does have a USB port or some kind of serial port. So we have a IoT hardware that is able to communicate with those instruments, send the right commands, and pull the data out. That's the same kind of hardware that we're using to measure the environment parameters of those of the lab, or for example, the temperature of the freezer where you're storing important samples. So by connecting all those different components in the R&D labs, such as instruments, lab systems, and your outside collaborators, we're providing 2 main category of products. The first one is data integration, a configurable way, a vendor-agnostic method for you to move data around across your lab. The second one is around operational efficiency, essentially help you to figure out who are using your instruments, what projects that is related to, and also how often the instrument is broken. So what is unique about this approach, as I mentioned, is our pure focus on integration. We're not a data analytics company just yet. We focus on moving the data from system A to system B. We are vendor agnostic. We also perform normalization such that you can treat data from different vendors the same way. And most importantly, this is not a consulting, this is not a service, this is not an in-house development. It is a commercial product that you are able to license. Because it doesn't make sense for you to build a road from New York to Boston because there are so many people using that. It is meant to be delivered to you as a product. So look forward to have more conversations. Thank you.
Thank you, Spin. Next speaker is Duncan McCallum, CEO of Digital Alloys. He holds a bachelor's and a master's from MIT, and they do multi-metal 3D printing. It was a spin-off from another MIT 3D printing company called NVBots.
Thank you, Marcus. Good morning. So the promise of metal printing has created incredible excitement in industry, right? It's incredibly valuable to be able to go from a part file to a part in your hand instantly, right? I mean, that time has incredible value. And with 3D printing, we can make parts that can't be made any other way. So why is the adoption so limited? It's cost. It's cost too much to produce a metal part on today's technology, and that's the problem we solve. We've built a high-speed system that can print multi-metal parts at a cost lower than conventional manufacturing. So it's the first system viable for mass production. Just to kind of explain the state of the art and where the problem comes from. In manufacturing, your costs come from raw material and your machine hour and how much you get out of the machine hour. The dominant approach today is something called powder bed fusion. These systems take powdered metal, which is super expensive, and a lot of the powder gets wasted in the process. And then they melt the powder into solid form using a laser and electron beam melting from the top down. The problem is you're limited by physics. It's like cooking a turkey. There's a thermal time constant. You have to put enough heat in to melt the powder into a solid form, but you can only melt it from the outside in. So you're rate limited. It's physics, it's not going to change. So these systems are limited to maybe, with a tailwind, 2-3 kilograms a day. Very, very expensive. Our solution to the problem, we use wire instead of powder. We can use commodity wire. In our early testing, we use wire from Home Depot, so it's very low cost. We put the wire in a precision motion system with precision wire feed that moves the tip of the wire to the spot on the part where we want to start a print line. And we use different physics to melt the wire. We use something called Joule heating or Joule printing. This is the same as a filament in a light bulb or the coil in an electric heater. The benefit of Joule heating is there's no thermal time constant. You can melt the metal instantly. So our print rate is limited by how fast we can move. So we can do many, many kilograms an hour, like 10 times faster than the state of the art. It's very low power because there's no thermal time constant. 90 or 10% the power of the current systems, which has a lot of benefits, not just in power savings, but in the quality of the metal that gets printed. And it's the only metal printing system in the world where you can measure directly what's happening in the melt pool. So a higher level consistency, and you can use that process data with machine learning to predict the quality of the part. And then just to give an example, we're working with Nemak. We're working with dozens of customers. Nemak's one example. They're one of the world's largest producers of aluminum cast parts. The tool you see here is used for casting aluminum cylinder heads. It's made out of an H13 tool steel, which is really, really expensive to cut. A lot of the cost is in the scrap and in the time on the CNC machine to generate the scrap. And those are the costs we eliminate. We'll deliver this part to Nemak for about 25% less than it costs them today. And it's a valuable new shape. I don't know if you can see the faint lines inside. Those are conformal cooling channels. So it's a shape you can't make conventionally. And with cooling channels, you can cool the mold so the aluminum cast part hardens more quickly and reduces cycle time. And every 1% change in cycle time is worth more than the cost of the mold. So it's a shape you can't get any other way. We'll deliver it for a lower cost than it can be delivered for using conventional manufacturing. And this is true across a wide range of applications. Our sweet spot is parts that are made from metals that are hard to cut. So that's Digital Alloys. I'd love to chat with anyone who has an application they think might be a fit. Thank you.
Thank you, Duncan. Our last speaker is Veronica Stelmach, co-founder and CEO of Mesodyne, and she's a postdoc researcher at the Institute for Soldier Nanotechnologies at MIT, and they have a technology that generates energy on the fly. There we go.
Thank you, Marcus. So I'm Veronica, and I'm the CEO and co-founder of Mesodyne, and our goal is to create a new kind of portable power. So what do all of these applications have in common? You need portable power, or you don't have access to the grid. And until today, or as of today, the solution for any kind of portable power is just batteries. We pile on batteries. But as you all probably know, our phone dies in the middle of the day, but we can go and recharge it at Starbucks. But a lot of applications, you don't have that opportunity. So in remote locations, people might use a portable diesel generator, but of course it's not really all that portable. So a lot of research has gone into leveraging the extremely high energy density of hydrocarbon fuel at this intermediate scale, but until today no one has really demonstrated a working technology. So our technology uses thermophotovoltaics, and if you've heard of thermophotovoltaics before, that's because it's an old technology. All it is you burn fuel, you generate heat, and the light, which is infrared, is then converted to electricity using a low band gap PV cell. But it's always been pretty inefficient because that spectrum is very broad, and the low band gap PV cell can only convert a very specific range. And with our novel photonic crystal design, we've actually enabled a new kind of efficiency for thermophotovoltaics because we spectrally enhance the radiation only in the convertible range. So we demonstrated the world record for hydrocarbon TPV in our benchtop experiment. We burned 100 watts of propane. We generated 5 watts of electricity. That's a 5% efficiency fuel to electricity. And while that number seems low, it's actually it's a lot of energy density because with hydrocarbon fuel, you only need to leverage a small percentage. And one of the great things about our technology is that it's virtually silent. There's no moving parts. You can use any kind of fuel in principle. Unlike fuel cells, which need refined fuel, we can burn, in principle, any fuel. We've demonstrated propane, butane, and we have an Army Research Lab collaboration for JP8 logistics fuel. And we also have no charging time since you just add fuel and you're good to go. And like I said, it has extremely high energy density. So we're currently moving our technology from the benchtop to this portable prototype here, which is our working prototype that Walker, my CTO, is holding in his hand. So we like to say we're generating watts of electricity at the fuel flow of a lighter in the palm of your hand. So we're at the Institute for Soldier Nanotechnology, and we've done a lot of work for soldier man-portable power, and that's an area where we think we have a great product market fit. So this example here shows the number of batteries the weight of the batteries that a soldier carries on average for different lengths of missions. And as you can see, with our solution, you would cut the weight from half to much more as you go forward with the mission. So about a 3 to 4 times weight reduction, which is a great value proposition for the soldier. But one of the reasons I'm here today is because we were naive. We thought, oh, we have this great technology, the Army will come and buy it tomorrow. But it takes time to work with the military, and we're really excited to also have commercial industrial application. We've identified some need in the oil and gas industry for pipeline monitoring, traffic, backup power. We've looked also at campers and emergency response. So if your company is interested in our technology and working with us to design the prototype and taking it to the next level, and that can mean just giving us the requirements for power. We're really interested to hear about that. Thank you.